Hi everybody. Today we're talking about finding function values of an angle. So go ahead and write down the title in your notes and put the date, and then go ahead and put your pencil down for a little bit. So what we're talking about in this section are going to be looking at the actual trigonometric functions, and what we're going to be working with are the sides of this angle. So when you draw an angle, you start here at the initial side and you rotate either clockwise or counterclockwise, depending on if it's positive or negative. This is a positive rotation. This angle stops here, and what you can do is you can draw this perpendicular. The reason that we do that is then we can analyze the sides of the triangle: side X, side Y, and side R. These sides will form trigonometric ratios. There are 6 of them, and that's what we're going to be working with now. So you definitely want to copy this into your notes. This is a super important idea that we're going to be working with throughout this chapter, and we'll actually work with it as we work our way through this course. So there are 6 trig functions that you'll be using in this course. You can look at page 22 in the textbook. It's in a brown colored box at the top of the page. Go ahead and look in your e-textbook if you want. And I'm going to go ahead and fill them in here as well. So go ahead and write this in your notes. The 6 trig functions that you need to know are going to be sine, cosine, tangent. We also have 3 more: cosecant, secant, and cotangent. And what we're going to do is fill in those relationships. So sine, and again, this is all going to be based on this triangle here. So you've got the X and the Y, and the R is called your hypotenuse, and we're going to use those sides to look up these different relationships. So the sine is always going to be Y over R. And again, this is coming right out of the book. I'm looking at that brown box at the top of page 22. So sine is Y over R. The cosine, in order to get the cosine, you put together sides X and R. Tangent is always going to be the Y over the X. And the other thing that it says in your book is that for the tangent, X can never equal 0. If it does, it's going to be undefined. So this X value can never equal 0. R will never be 0 anyways, so you don't have to include that in that one. Let's go ahead and do the other 3. So sine and cosecant are just reciprocals of each other. So if sine is Y over R, then the cosecant will be R over Y. Cosine and secant are reciprocals. So if this is X over R, then this will be R over X. And then finally, if you've got Y over X, then this will be X over Y. Now for these reciprocals, since Y could possibly equal 0, we need to just kind of clarify that Y will not equal 0. If it does, it would be undefined. The X here should not equal 0. If it does, it would be undefined. And then again, Y does not equal 0, undefined. So that's going to be our 6 trig functions: sine, cosine, tangent, and then cosecant, secant, and cotangent. And you're going to be really familiar with those. We're going to use them a lot throughout this course. So we have a terminal side of an angle theta in standard position, and I would write this down in your notes. So pause it now if needed. So we have the standard position. It passes through the point given. Find the values of the 6 trig functions of angle theta. Okay, so this is your new thing here. We have this symbol right here, and this symbol is called theta. That's how you would pronounce that, theta. If you've never seen theta before, it's a Greek letter. You will see it a lot from here on out. Okay, so I'm going to graph the point 12, 5. What that really means is that I have an angle that starts here in this initial area on the initial side, and it rotates up till that point. So I have an angle here, and this is 12.5. What I can do now is I can drop a perpendicular. So I can drop a perpendicular, and I can label the sides. And when you drop a perpendicular, you always go towards the x-axis. This is our x-axis, and you're always going to go towards the x-axis. Okay, so if that's the x-axis, that means this is my x side. This is your hypotenuse. The diagonal angle, or the diagonal side, is always the hypotenuse, and that is always labeled letter R. And then finally, this other side, which is parallel with the y-axis, is always known as y. So those are the three letters you're always going to use here: x-axis, hypotenuse, and the other one will be y. So what we're going to do is we're going to find the 6 values of this trig function, and we already know a couple of them. Here's why. This point was 12 units over. And this point, the y value, is 5 units up. See it? This is x, this is y. So x was 12 and y is 5. What we need to figure out is how to find the r. So I'm going to flip back to the original slide. In order to find the r value, all you're doing is you're doing the leg squared plus the leg squared and then taking the square root. You're really doing what's known as the Pythagorean theorem. If this was a squared plus b squared equals c squared, we would just simply be finding the square root of that. So we're doing the Pythagorean theorem. Okay, so let's look at how this is written here. To find r, you take x squared plus y squared, and then you're going to square root that. So let's plug in what we know. According to this, and according to our picture up here as well, the x is 12. And according to our picture, and according to this side up here and here, the y is 5. Go ahead and do the calculations. Use your calculator if needed. Okay, so I got 144 plus 25, which equals 169. That one is a perfect square. It's not always going to be a perfect square. This one is. If you take the square root of 169, you get r equals 16, or r equals 13. Okay, I'm going to go ahead and put that into my picture. So r equals 13, that's the length of the hypotenuse. All right, now what I'm going to do is take these given sides now. I've got 2 sides that were given, one side that I found, 2 legs and a hypotenuse, and I'm going to write them into the 6 trig functions for theta, with the th, theta. So I've got that kind of listed out here below. Go ahead and pause the video and fill in these 6 trig functions: sine, cosine, tangent. I call these the big 3. These are your main ones, and then the other 3 are just going to be reciprocals of the other. So again, if you need to pause, go ahead and pause now. All right, let's go ahead and fill in these trig ratios. Sine, according to what we just wrote here, is y over r. So keep referring back to that as you're filling these in. So we can take a look at our y. Our y is 5, and our r is 13. So we're going to write 5 over 13. Reduce if possible. This one doesn't reduce. Okay, cosine. Cosine is x over r. So let's go ahead and fill that in. We've got the cosine is right here. X is 12, and r is 13. So we're going to write 12 over 13 for cosine. Reduce if possible. This again doesn't reduce, so we're good there. Okay, then finally we need the tangent. The tangent, according to this, is the y over the x. So let's look at our y. Y is 5, x is 12. So 5 over 12. Now, the good news is once you have the main 3, the other 3 are literally just your reciprocal. So you're going to take the 5 over 13 and you flip it over. So instead of 5 over 13, it's 13 over 5. Instead of 12 over 13, 13 over 12. 5 over 12, 12 over 5. Okay, so those are your 6 trig functions of this angle theta. So this is our theta right here. And we just found the 6 trig functions for theta. So example 2 is -3, -4. So go ahead and pause and write this down. All right, what I'm doing is I'm going to draw the picture, the diagram of -3, -4. So 3 to the left and 4 down here. That would be approximately -3, -4. What that really means is that I have an angle here that begins at this initial side and rotates around until I hit that point, which is right here. Okay, so this is a big angle that rotates around here, and what I need to do is I need to figure out a triangle that I can actually use to calculate. So I'm going to take my pen or pencil and I'm going to drop a perpendicular towards the x-axis. Always go towards the x-axis. You'll never drop a perpendicular left or right. You'll always go to the x-axis. And let me kind of move this out of the way because it's a little, guess I can't move that. That's okay. All right, so there's my triangle. You can kind of see it now a little better. And what I'm going to do is I'm going to label the sides. If this is the x-axis, then that means this is x. So this is x-axis, that's my x side. This is my hypotenuse. The diagonal line is the r value, that's the hypotenuse. So that means the one that's parallel with the y-axis, the other side would be y. Let's fill in what we know. This is x and this is y. We went 3 units to the left. Be careful, we're going to the left, so that means we went -3. So again, see how this is a -3? We went 3 units to the left, so that's -3. We moved 4 units down. See, this is a -4, so y equals -4. And then finally, we can calculate our r value. Again, I'm just using this Pythagorean theorem from the beginning of the set here. Instead of a squared plus b squared, you're going to use x squared plus y squared. And that's going to equal our hypotenuse. So x squared plus y squared is going to equal the r squared, and then we square root. Okay, our x value is -3. The y value is -4. Don't forget, you are squaring it, so it's a negative times a negative, which makes positive. -4 times -4 is positive 16. This is still under the radical. These aren't always going to come out as perfect squares. If they don't, you can just leave it as a simplified radical or simplified square root. But this one, again, our square root of 25 is just going to be 5. So I'm going to label that in my picture. All right, I have all of my sides. Now I just need to set up the ratios. Start with the main 3, sine of theta, again, T-H-E-T-A, sine of theta, cosine of theta, tangent of theta. The other 3 are going to be the reciprocals of those 3 that you find over here. So go ahead and pause and write them if needed, and then we're going to fill them in. So definitely as you're learning these, use your notes and look back at the relationship. Sine is always y over r and cosine is x over r. So let's take a look at our picture. So sine is the y over the r. So -4 over 5. And cosine is x over r, -3 over 5. Let's look back at tangent. So tangent is y over x, y over x. So we're going to fill that one in. Let's see, our y is -4 and our x is -3. There's one of these that we can simplify. That would be this one. A negative divided by a negative is actually a positive, so you can just write this as 4 over 3. Okay, now for the reciprocals, the other three are simply just the reciprocals. So what I tell people is cover up the negative, flip it over, and then put the negative back in front. So cover up the negative, that would make this 5 over 4, and then you can put the negative back in front. It doesn't matter if you put the negative in front of the fraction like this, or with the top number of the fraction like that, or even at the bottom. That's fine too. As long as you only write it once, not twice. So anything that you do is fine here. Okay, let's do the same thing. Again, cover up the negative, flip it over, so that would be 5 over 3, and then put the negative back in front. Oops. Okay, and then last but not least, use this one since negative makes positive, and I'm going to write 3 over 4. Okay, let's try one that's not an exact value. How about 1 and then square root of 3? So I'm going to go ahead and pause and draw this if needed. I'm over 1 unit. And square root of 3, if you use your calculator, it's about like 1.7-ish. So you can kind of put it up here. So it's over 1 and up a little bit beyond that. Not quite to 2, like 1.7. But again, the idea is this is an angle that starts at this initial side and rotates counterclockwise, stopping at that point. So this angle would just go out further here. All right, now what I'm going to do is I'm going to drop my perpendicular. So you don't have to make it really small. You can if you want. You can make it a little bit bigger. The idea here is that what we're looking for are the x and the y and the r. So remember, this is our x-axis. This is the hypotenuse, which is r. And then that means that other side would be the y-axis. It's always parallel with the y side. So the y side will be parallel with the y-axis. Look at your x and y values. X is equal to 1. Y is equal to the square root of 3. That's what we have here. And r, the hypotenuse, will be the Pythagorean theorem answer, which we can do right now. We're going to take the x squared plus the y squared and square root. Okay, hopefully you know 1 squared, 1 times 1 is 1. Square root of 3 times the square root of 3. Here's what happens. Square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So if you take a number that's a square root and multiply it by itself, you just end up with the number. So square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. 1 plus 3 is 4. And so r would equal 2. Again, fill it into your picture. Once you have this part figured out, now you're simply just setting up these ratios. So go ahead and pause if needed and write out the 6 trig functions below. If you need to look at your chart, you can go back and find sine. Sine is always y over r. So in your picture, square root of 3 over 2. The cosine is always x over r, so 1 over 2. The tangent is always y over x, and I'm getting this off of the chart, y over x. So root 3 over 1, which you could just write as square root of 3 or root 3. The cosecant, secant, and cotangent are going to be the reciprocals. So I'm going to go ahead and flip this over. So 2 over root 3, I'm going to have to rationalize that in a moment. This is 2 over 1, which just equals 2. And this, go back to the original to flip it. It's going to be, instead of square root of 3 over 1, it's 1 over root 3, and we're going to have to rationalize it. So here's how you rationalize it. When you were doing this back in your other classes and you thought, when would I ever need this? Now you're going to need it. You are not allowed in math to leave a square root or radical on the bottom in the denominator. So what you do is you multiply it by itself. Square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So if you take a radical times itself, it just gets rid of that root. And then this would just be 2 root 3. So that's considered simplified. Okay, let's do the same thing with this one. Times root 3 times root 3. So you get square root of 3 over 3. And then that would be considered simplified. That's called rationalizing the denominator. So the last example deals with an angle that sits on the axis, either the x or y. So this is the point 0, 2. And 0, 2 would be up here on the x-axis. It would start here, rotates around, and it would end straight up like this. So you wouldn't actually be able to draw a triangle. So here's what you know. You've got the x and you've got the y. So x is 0, y is 2, and what we need to figure out is the r. So we're going to use the same method. Even though we can't drop a perpendicular and draw a triangle, you could still plug in the given information. So this would be 0. 2 times 2 is 4. So r equals 4. Oh, square root of 4. So it doesn't equal 4. It equals the square root of 4, and the square root of 4 is 2. So I fixed that there. Square root of 4 is 2. So I'm going to label that in my picture. So what they're saying is this length from here to here. So I guess I really don't even have to label it this time, as long as we have the information. X is 0, y is 2, and then r is 2, which is what we just found. Pythagorean theorem, that's what you're really doing. Okay, let's plug it in. Again, these are your 6 trig functions. So go ahead and write these down. And let's plug it in. So sine is always y over r. And again, that's just from that chart. So 2 over 2. And that reduces to 1. The cosine is always the x over the r. Now you can have 0 divided by 2, it just equals 0. The tangent is the y over the x, y over x. If you try to divide 2 by 0, you end up with an error in your calculator, so this one is undefined. So this is considered an undefined and up and down area on the graph, and we'll see how to graph those later. Okay, now these other ones are going to be the reciprocals. So if this was 2 over 2, it's still going to be 2 over 2, which is still going to equal 1. Cosine, which was 0 over 2, is now going to be 2 over 0. Again, I'm flipping these over, reciprocal. So now this will be undefined. And then finally, this originally was undefined, but when you give the reciprocal, it's now going to equal 0. So these are the assignment problems for this set. Have a great day.